This is something I talked a lot about in my other courses. So the first 4 years, replications and extensions, that these two took part in. There's a reason why we did replications and extensions at HKU. And one of the reasons for that is this. So I really think that every talk that I give needs to start with this. So starting from 2011, we realized that we have a problem in social psychology. And the problem was that there were a few findings that seemed to be too good to be true, to the point of being impossible. And how did we know that we have a problem? We tried to repeat those again and see if we get the same kind of results. And then 2011, some studies came out that seemed impossible. So we tried to repeat those and we failed. All of these disciplines, economics, chemical research, medicine, biology, physics, told us psychology is the problem, because if you go to the hard sciences, the exact sciences, there's not going to be any problem. And then psychology challenged the others, can you please show us if we do replications, reproductions of research in your domains, are we going to get the same kind of results? And then in 2015, these kinds of results started coming out. So I took a bunch of headlines. You can see the headlines over there, 2017, Washington Post, science reproducibility problem is not limited to psychology. In medicine, science has stopped working. Chemical research, there's a problem. Cancer research is broken. There's a big paper that came out a few months ago that only 8 out of 193 in cancer research in medicine replicated, reproduced well, and the others, there's issues with that. And then we thought maybe if we go to the more exact sciences, computer science, like very close to math or physics, quantum mechanics, quantum computing, then we'll get something better. But then we realized we also have an issue over there. So this is a science problem. So we don't have too much time to go into what the issue is. I have a lot of lectures. You can go on my website. You can go to the previous year's lectures. This is not the point of this course. We've shifted from open science and the problems with science to a different direction. But I do emphasize empirical evidence credibility. So I want us to focus on things that are credible. There's a reason why I'm mentioning this, because I'm going to give a case study, and through those case studies, I'm going to make a point. Some of you are doing a thesis that might be related to this, so you're thinking of building your thesis on something like that. This is a classic paper in social psychology. It's about priming. It's from 1979 by Sewell and Wire. Wire is actually here in Hong Kong. He's already retired. Him and his wife came to HKUST, then he moved, I think, to CUHK. So he's part of our Hong Kong community, very well respected. I knew him and his courses. He was in the marketing department when I was in the management department. Terrific person, very nice, very impactful paper. If you look at how many citations, this is the Google Scholar. You can see 1979 citations. 2,463. Since then, I'm sure that it went up a little bit. What is priming? Over here, what they did is hostility or kindness. So what they did is they unscramble sentences. So they let people, you have words, and then you have to create a sentence out of that. And then from that, it's supposed to activate hostility in your mind. And then it's supposed to affect some kind of DV. The main question is, something that has been cited 2,400 times, appears in every social psychology book in many chapters. And it's something that every year, at least one thesis student at HKU wants to do something about this and asks me, what do I think about this? Would this replicate? So this is our attempt at a replication, 2018. You can see that the protocol was vetted by Robert Wire, so Sewell and Wire. This is the second author. This was published in Advancing Methods and Practices in Social Psychology, and you can see all the names of the people involved in this. So not 2 people anymore, but a lot of people that I actually know and collaborate with. Some of them have helped us at HKU, worked with our students. So big names over there. And we wanted to know, does the first experiment from this seminal paper, does this replicate or not? And then what the end result was, that although the confidence interval for one outcome excluded 0 and the observed effect was in the predicted direction, these results suggest that the currently used methods do not produce a priming effect that is practically or routinely detectable. So a lot of labs from around the world, look at how many, all these are different labs. This is a meta-analysis of all the replication attempts for that classic finding. If you look at the middle one, the dotted line, this is the 0. So if this touches the 0, the confidence intervals touch the 0, then there's no effect. You can see the confidence intervals over here, over the effect. The original effect was 3.01, a Cohen's d. I can already tell you that this is an impossible effect. We'll touch on this in the next slide. But if you look at the other ones, aside from one, all of the others are touching on the 0 with the confidence interval. Some of them are even to the left of the 0. So this is not what we expected to find from something that's this seminal. What to make of this? I don't know. Randy, who is the guy who did this whole thing, he's the first author at the of this mass replication. It's amazing that he was able to get all the labs together to do this sort of thing. Everybody told him, of course, this would replicate. From 1979, 2,000 citations, nothing to worry about. But then he wrote this tweet, which is one of the reasons that alerted him to, maybe we need to look at this more carefully. And what he wrote in this tweet is that a previous meta-analysis computed the effect size for a swirl wire to be d equals 5.6. This is obviously wrong. I mean, look at the reported F ratios. Now, some of you, F ratios, effect size, we don't know what to do about this, but this is like a meta-analysis. Usually the meta-analysis shows effects, 0 point something, 8 is very large, 5 is medium. To have 5.6, this is impossible. There's no effect in social psychology that has this. If you look at the F, you can see 123.74. We don't have anything like that. There's nothing in psychology that we do that has this kind of effect. In addition, this is what James Heathers says. This figure is just too perfect. If we have a four-way interaction, I can maybe visualize a 2x2. Three-way interaction, it just blows my mind. Four-way interaction, I don't even know how to look at this thing. But they had predictions for a four-way interaction, which worked beautifully. And if you look at this figure, everything just like very well coordinated with a sample size of 80. If you think about the implications of a small sample size, is that the error is very, very large. It goes in all kinds of directions. So to have this kind of beautiful figure, what does that mean? Something here is very, very wrong. It's not just that something here in this article is very wrong. Something in our science is very wrong because nobody noticed this from 1979 to 2018. Nobody did anything to check this. Nobody did anything to replicate this. Nobody did anything to check with the journal, with Bob Wire, what exactly happened over there. We don't really look and read our literature. Some people said, okay, the reason why you couldn't replicate this is because from 1979 until 2018 or 16, where the first one started, things changed. So you need to adjust things. You can't just do a direct replication, you need to do a conceptual replication. So once again, poor Randy got another team of all these labs, all of this trying to do both a close and a conceptual replication. And the conceptual replication, they sat together with Bob Wire and all the priming effect literature people and said, help us, we really want this to work. We need priming to work. Help us make this work. What is the result? The hostile priming effect for both the close replication, 0.09, and the conceptual replication, 0.05. It's even lower for the conceptual one. Shows that there's no support for priming effect. Despite our best efforts to produce favorable conditions for the effect to emerge, we did not detect a hostile priming effect. We suggest that researchers should not invest more resources into trying to detect this. Every year, at least one HKU student here in our department tries to follow up on priming effects. And we're just like one university, one department. People keep following up on this. The citations keep piling up every year. I see more citations of this. But look at this effort. So many people, best effort that we can on this. Why am I sharing this with you? So I already tried to tell you that we need to find credible evidence. How do we know what is credible and what is not credible? So we have all sorts of reasons for why this is happening. I discussed this in my other lectures, but we have all sorts of very concerning signs. Implausible, impossible effects, no transparency about the process. There's no sharing of data code. We don't know exactly what happened in 1979. And for many decades, nobody even tried to follow up on this. Unfortunately, if we ask the priming people, what do you think about this? Business as usual. John Barge, one of the priming effect people, published a very successful book, New York Times bestseller in 2018. Before you know it, the groundbreaking work of nonfiction revealing the powers of the unconscious mind, just like Daniel Kahneman's Thinking Fast and Slow. Remarkable. I don't understand this, because this book came out after of all the failed replication attempts, and not just one. You think just one? No, a lot of articles in priming don't replicate. Commitment priming, honesty priming, intelligence priming, death priming, all these mass replication efforts, so many labs, millions invested in this, so many hours. We can't seem to replicate social priming effects. In every social psychology book, this is a problem. Why am I mentioning this to you? Why do we need to discuss this? Because of this guy. This guy is one of our top psychologists. He's the only psychologist to ever win the Nobel Prize. This book, Thinking Fast and Slow, is very reputable in our field. It's kind of like the Bible of judgment decision making. I build a lot of my research on this. What I did with HKU students builds on many of the findings here. He created by himself with Amos Tversky, these two folks created a whole field of behavioral economics and judgment and decision making. Now, the thing about this is that although this is an important book, it's a very difficult book. It came out in 2011, and I've tried many times to read this, and I failed, because one chapter, second chapter, I fall asleep. It's very, very, very difficult, very challenging, very dull. He's not a very engaging storyteller. Oh, you tried as well? Very difficult. So I put this aside for a long time. Plus, I have to say, being an academic, I spend my whole day reading, and then having to go at the end of the day to read another book, which is dull. It's not easy for me. So I left it aside for many years. 2016, I discovered audiobooks. And finally, I don't have to dedicate my whole time just to looking at a thing. I can do something else. So I listen to this while I'm at the gym. First chapter, great. Second chapter, fantastic. I can do my thing and listen to this. But then fifth chapter, sixth chapter, I had to stop the treadmill and go sit on the side and listen very, very carefully. Why? Because Daniel Kahneman was saying in that book, he was covering all of the priming literature findings and saying that this seems like the future of judgment decision-making. This is the most promising effect in our literature. And I remember doing my PhD, everybody was trying to do priming. I can't tell you, I stopped counting how many priming effect studies I've tried. I thought that I was stupid. I thought that I was incompetent. I couldn't get these things to work. So I just like, this is beyond me. Maybe I'm just not a good researcher. So I put this aside. But then I realized it's not just me. There's some other issues in there. But Daniel Kahneman, also thought that this is a big thing. This is the email that he wrote 1 year after his book. This email became public. He wrote this to the priming literature people. 2012. As you all know, of course, questions have been raised about the robustness of priming results. Your field is now the poster child for doubts about the integrity of psychological research. People have now attached a question mark to the field and it is your responsibility to remove it. Get yourself together and solve this thing. Why? All I personally have at stake is that I recently wrote a book that emphasizes priming research as a new approach to the study of associative memory. Count me in as a general believer. This is Kahneman, our top psychologist. My reason for this letter is that I see a train wreck looming. And then the big headline from Nature, Nobel laureate challenges psychologists to clean up their act. Now, what's remarkable is that Kahneman is not a young person anymore. Now he's like 85 or so, or even beyond that. And some of us in the open science community try and understand what was going on with this priming literature. So what is it? Is it questionable research practices? Is it something else? Publication bias? What is going on over there? And one of the people in the open science community wrote a blog post where he analyzed all of the findings in the chapter in Thinking Fast and Slow about priming. And then he indicated that there are some big problems, and we should have known that this would not replicate because p-values are just below 0.05 and the samples are very, very small. So in 2017, he goes on this blog, an 80-something years old guy finds an anonymous blog from somebody in the open science community and writes this, which is remarkable for Kahneman to go and comment this. What the blog gets absolutely right is that I placed too much faith in underpowered studies. The samples were just too small. As pointed out in the blog, there is special irony in my mistake because the first paper that Amos Tversky and I published was about the belief in the law of small numbers, which allows researchers to trust the results of underpowered studies and unreasonably small samples. The first paper that he published with Amos Tversky that led to the Nobel Prize was that he went to statistician conferences and he showed something that looks like priming effect studies to statisticians and says, do you trust this? He gave them this example. Suppose you run an experiment on 20 subjects and obtain a significant result which confirm your theory. And he said, you should all be careful. And what is amazing is that he warned the world about this. And he is the one who fell into this trap. Our article was written in 1969, published in 1971, but I failed to internalize its message. So even the great Daniel Kahneman fell into the trap that he warned the world about. How tragic is this? If Daniel Kahneman falls into this trap, all of us can fall into this trap. So we really need to check ourselves all the time. This is a remarkable case study. So remarkable. So this article cited 4,200 times, really groundbreaking work, started this whole field of judgment decision-making. Belief in the law of small numbers is really something that we need to take into consideration in the scientific literature, in the EA movement, in everything that we do in finance, whatever the field is. This is very, very important. We need to understand the evidence that we have and whether we can trust this or not. And this is one example how understanding judgment decision-making in social psychology has implications for everything, for how we do science. And we can study these things effectively by doing research like this. This is his reflections afterwards. He did an online live. They put him into like an influencer sort of setup and then interviewed him, and this was published in Edge. Well, I was wrong, at least in that case. The studies of behavioral probleming that I had studied in that chapter were largely discredited in the famous replication crisis of psychology, which is remarkable, you know, him saying this. There's essentially no takers for my suggestion for priming research, that priming researchers should proactively replicate each other's work. Now, what's your takeaway from this? He realized that he had a problem. He called others to try to solve this problem. He saw that the problem was not solved. And then he said, I don't believe in this anymore. I made a mistake. What do you think about this? Should we applaud? Should we criticize? Should we care? First, we should say, well done, Daniel Kahneman. Not a lot of researchers do this. You made a mistake. You tried to follow up on that. You realized that there's no possibility of solving this, and you owned up to it. Still, although we congratulate Daniel Kahneman in our field for this, something is missing. What is missing? I'll tell you, and I spent a lot of time thinking about this. When I saw this happening in 2017, I was a postdoc in Maastricht University about to get a position at HKU. What should I do about this? To me, this is groundbreaking because I spent my whole PhD working on priming effects and seeing how everybody else telling me that I should build a career on priming effects, what I should do with this. So he says, the crisis has been great for psychology. It's been the best decade in my lifetime. Behavioral priming research is effectively dead. And to me, this whole thing was an example of a bias blind spot. So Daniel Kahneman was warning the world about having biases. He was warning the world about statisticians that cannot understand statistics very well. And then he did not realize the bias within himself. Even after he realized the bias in himself, he still did not realize another bias in himself. And that bias is, I'll just say that we did a replication of the bias blind spot. So first, I want to say that the bias blind spot replicates very well. So you can see the list of HKU students that are co-authors on this manuscript that was just published last year in Judgment and Decision Making. So what you can see over here, it was covered by the British Psychological Society Research Digest about the students doing a really good job at replicating the bias blind spot. Then I ran this in my courses. So here you can see how this was demonstrated as a bias blind spot. So you can see I asked students in 2021 to rate themselves on dependability, objectivity, consideration for others, snobbery, deceptiveness, and selfishness. So 3 positive traits, 3 negative traits. And the students, just like in our research, rated themselves higher than the midpoint on the positive and lower than the midpoint on the negative. So definitely there's a self-serving bias over here. Then we told the participants that this is what's happening. And then we told them, this is what you indicated. There's a very famous study that there's self-serving bias. Do you think you have self-serving bias? So even after we explained the bias to them, then we asked them to again rate what's your self-serving bias compared to other self-serving bias, and they still rated others as having more self-serving bias than they. So even after we explained this to them, just like with Daniel Kahneman, he explained this to others. He knows about self-serving bias, he knows about all, still they demonstrate the bias blind spot. So bias blind spot is very alive and well, happens. It's everybody else is more biased than I am biased, right? Back to Kahneman, what did he miss? He was telling priming researchers, go check yourselves. You need to go and verify your small samples. My question to Kahneman, did you try and replicate your own work? How do you know the judgment and decision-making really works? Did we try and replicate the JDM findings? How is this different from social priming? How do you know that JDM is better? So rather than calling others, check yourselves, what could he have done? Saying, I'm now taking responsibility and I'm going to check everything that I've done with small samples. I'm calling my field, calling all JDM researchers to do this. He did not do this. Now, I don't have a direct link to somebody like Daniel Kahneman, but again and again, me and other people in the open science community that care about JDM called others. Let's please try and replicate this. So 2017, I really cared about this. And nobody was picking this up. Just like they didn't pick this up in priming, nobody was picking this up in JDM. Why should we check ourselves? So who is it left? Who needs to take care of this? We do. HKU students need to clean up this mess. We need to do replications of the bias blind spot. So we did 100, 120 of these ongoing. We're the only ones that are doing a systematic review of replicating all the effects in judgment decision making. Not everything replicates. Some things don't replicate, but at least we take responsibility for what Daniel Kahneman was saying. So I took a lot of inspiration from this case study. It's not something that I'm just telling you as, reflect on this. This is something that has determined my path, my academic path, in order to understand where I am, how I want to do my research, what I want to build my research on. So after 4 years, you can see we completed the 80 with data, 40 register reports, 3 meta-analyses that are completed, 3 meta-analyses that are in process, prediction markets, and a lot of guides. As you've seen, we have a bunch of collaborative guides. And honestly, I could not have done this by myself. I can only guide HKU students to do this. But the JDM field, the judgment and decision-making field, would not be credible to many if it was not for HKU students picking this up. So Daniel Kahneman saw bias in others, but did not do anything to clean up his own act, which is a shame. We covered all of this already. So we tried to verify all of that. So by now I have a fairly good understanding of this literature, and I know what replicates and what doesn't replicate. And we set some directions for the future. Another nice thing that you can do after replicate 120 of those is that in the literature, this is the best that we have. Some consultancy group wrote this. This is what appears in Wikipedia. Try to map this out and categorize these, but this is a problem because it's not like a science-based sort of mapping. So we try best we can on the evidence that we have from the replications to offer default models and integrate them into something that makes sense. More replications, blind spot, and so forth. One of the things that we replicated is self-interest is overestimated. What people think others would do. So you can see over here the list of HKU students. Cameron came in and helped us to integrate this. So we had 2 teams of 2 students, one running this in the Amazon Mechanical Turk with American participants, and the other sample running this on Prolific Academic with British participants. It's amazing because both of these samples almost one-to-one. You can see the integration of these 2 samples together. So about 2,000 participants. And what we did over there is that we asked people what they think others would do if they had self-interest to do something. So for example, over here with blood donations, we said, how likely are people to donate blood if they were paid or if they were unpaid? And people said, oh, if they're unpaid, they're not motivated to do this, so the rate is going to be around 40. But if they're paid, they're motivated more, they're incentivized by monetary incentives, and then it's going to go up to 60. Even more remarkable is this example over here. So policy support for banning smoking in public spaces. So people assumed that smokers are going to be much more against, approval rates for anti-smoking in public spaces policy. So about 30 for smokers and about 80 for non-smokers. But what's remarkable about this is that all of them overestimated this. Smokers and non-smokers both support anti-smoking in public spaces. Regardless of whether people get paid or not paid, people want to donate blood, and actually payment does not change their incentive. Therefore, self-interest is overestimated. We think others are incentivized by money. We think people are only thinking of themselves. But when it comes to blood donations or when it comes to smoking, people actually overestimate how self-interested people are. Why mention this in this context? There's a reason, aside from a very nice replication by HKU students. We have a lot of back and forth me as a replicator with the HKU students and the original authors. We all assume self-interest in others, and we don't see the self-interest in ourselves. Sometimes I need to stop myself and think very carefully, do I have an interest here? Do I have a bias here? So we get into arguments where replicators think about original authors like, don't they care about science? What kind of thing is this, you know? So I'm thinking they think about me more than science. They want this to succeed more than science. My instead of our. They think they're better than me. But on the other side, obviously, if you ask people who we fail to replicate their work, very suspicious. He wants to take me down. He cares more about failing to replicate my work than succeeding. You know, he doesn't want to cooperate with us. He thinks that he's better than me. And obviously, I don't. I just want to fix science. I want us to get to the truth. I have no self-interest. I'm sure that if you talk to John Barge, why did you publish that book? I don't think he did this because he thought that he's fooling the world. I really think that he's a good, credible scientist that wants to do the best that he can in order to deliver a message to others. Perhaps there's some incentives in terms of money that he's getting from the book, but this is not why people go to be an academic. I can make a lot more money. No reason for me to go to academia. Generally, scientists who go to academia do not go there because of money, right? But we tend to get into this sort of thing because self-interest is overestimated. Another amazing example of social psychology applies to almost everything in life. This is a great example, not just with replicators, but also with open science. I really care about open science because I think this is the way forward. But it's not like other people at HKU who do not believe in open science. We have amazing scholars at HKU that don't think that I'm right. They've been doing science for 40 years and they think this is the way to go. And then we get into these conversations where they think about me that I think that I know better than they do, you know, that care about power, you know, this is a power struggle. So they think I'm too extreme, that I want to take them down, that I want to change the system. I want science, they want science, we just disagree. Sometimes we need to really consider if we're thinking that somebody else is doing something, why are they doing this? It could be because of self-interest, but most times it's not related to this, especially not in something like academia, especially not with something like effective altruism. We all want to help the world. We want to get to the truth. We just disagree on the way. So we need to keep this in mind. Happens to me a lot with reviewers and editors. For me, it's like, why don't you accept my publication? This is good science. So for me, I think they emphasize the journal impact factor more than science. They want to reject my work. They think that I only care about my publication record and I want to accept. So we get into these struggles. At the end, this is us. In order to get to the truth, we all need to work together. So this is what science should be. And I think just generally the message here is that we need to shift our defaults to assuming best interest. So if you see something not aligned with that, then we really need to think very carefully what is going on over there. We need to, as much as possible, disclose our conflicts of interest. So if there's something that might be biasing me, I should do something about this. Daniel Kahneman should be more aware of his conflicts of interest and what could be biasing him. We need to disassociate science from specific scientists. We need a lot of humility. The good thing about Daniel Kahneman is he's very humble. He's willing to admit his mistakes. And he invented this thing about adversarial collaboration. So if we disagree, get one from this group, one from that group, collaborate, and then you can publish something together as a register report. Confirmation bias. There's a case study that I want to share with you. It's kind of interesting and funny, but I think you deserve a 5-minute break. So go rest, refresh, and then we'll come back to the case study. 5 minutes. Do you know the guy on the left? Who's the guy on the left? He's a YouTuber that has over 10 million subscribers. I think it's already like 12 million subscribers. Veritasium. Strongly recommend this guy. Amazing science stuff. Mostly physics, but also occasionally, and we'll see he does some stuff on psychology. So terrific, really amazing stuff. In this specific case study, I'm going to let him introduce this, but this is amazing because it happened last year and it blew my mind. Because he had a post, a YouTube video, showing evidence for something in physics that he demonstrated that created a big controversy. And at some point, the guy over here, Professor Alex from UCLA, he's a professor of physics and astronomy, told him, this is impossible. You made a mistake. Something here is very wrong. This cannot happen. You need to take it back. And at some point, the YouTuber are like, really? I'm wrong. I'm going to bet $10,000 with you that I'm right. And the professor agreed. And this is what happened with this case. Familiar with this? No? Okay.
I am here to sign a document betting $10,000 that my last video is in fact correct. This is the video in question. Some people may have missed it, but in this car there is no motor, no batteries, no energy source besides the wind itself. And the counterintuitive claim is that this car can maintain speeds faster than the wind that's pushing it. There is a physics professor at UCLA who got in touch to say that he thought that I was wrong, that the explanation was wrong. You know, we went back and forth a little bit, and eventually I said, well, how about we bet $10,000? I can prove it to you, this vehicle really can go downwind faster than the wind. And to my surprise, he is taking me up on the bet.
Yeah, so I want you to pay attention both to how the YouTuber is talking about things, science, evidence, and then how the professor is talking about evidence, science. And I want you to tell me who is biased and regarding what. Okay, so pay very close attention. We've already seen Daniel Kahneman. Here's another case study.
Look, no one is perfect, but you have a much lower error rate than most people on YouTube, in YouTube space.
Now, Professor Alex Kosenko wanted this wager and all related discourse to be public. In fact, he suggested we get a celebrity to witness the signing. So I asked Neil deGrasse Tyson, Bill Nye, and Sean Carroll to be our witnesses, and they graciously agreed.
And Alex, I just want to say, I agree with everything you said about Veritasium, that generally I can watch it and not have to wonder, is he going to mess up? How am I going to...
No, he's brilliant. No, he's brilliant.
I'm excited about this bet because if I am wrong, then I want to know. Like, the whole point of the channel is to get to the truth, and that is, I think, why we're all here today, and I think, you know, this is a great chance to sort of see. I'm going to summarize Alex's main points in this video, but I'll put his full presentation here.
So let me first explain what I see in the video. In the video, the vehicle is operated in a gusty wind. Initially, you have the wind speed exceeding the car speed, but then the wind speed is not constant. The wind speed drops, and the car moves by inertia with deceleration for a while.
So basically, Alex thinks a gust pushes the car to a high speed, and then when the wind dies, the car is going faster than the wind momentarily, but it must be slowing down.
In fact, that will be my conclusion at the end of this presentation, that whenever you have velocity faster than the wind, I'll actually show you in an equation, the acceleration is negative. Okay? The second effect is that the wind in the video is measured at the height of about a meter or meter and a half, but the propeller goes to some 3 meters above the ground.
Now, due to interactions with the ground, there is a wind gradient. Wind travels slower, close to the ground, and then faster higher up. Now, Alex estimated that the wind speed at the propeller might be 10 or 15% higher than at the telltale. So it's possible that the car could be moving slower than the wind at the propeller, and yet appear to be moving faster than the wind at the height of the telltale.
Now, I think that this is a small effect. However, in combination with the previous effect, it just can make this more frequent. Okay, and that concludes.
If I remember the video correctly, Derek reports that they've achieved up to 2.8 times wind speed. That feels much higher than what is possible here, unless the wind had picked up and then spontaneously sort of dropped.
Very, very good question. Okay, if you're going for the record, you probably will do many attempts. You will be sampling that that gusty wind over and over and over until you set the record, right? That's how you set the record. And on one of those occasions, you will get a nice strong gust, which is 3 times the ebb that comes after it, okay? And that's when you will clock the record, and that's where that 2.8 factor will come in.
So what about the treadmill tests? These are conducted in still air. By moving the ground backwards, you're simulating a perfectly steady tailwind. And if you hold the car stationary on the treadmill, well, that's equivalent to the car going exactly wind speed. Now, if the car can move forward on the treadmill, that shows it can accelerate faster than the wind. But Alex had multiple explanations why these experiments don't actually show what they claim to show.
If you have this fluctuating speed of the treadmill, and then if a human just sort of steers it, it then can introduce unconsciously a bias towards the desired result.
So would it may be that the guy with the spork is inducing the model craft to go across the wind now and then?
So
and as you pointed out, Alex, it's going downhill now and then.
Yeah, I'm 100% sure that the guy in the video doesn't do it on purpose. Okay.
Yeah.
However, if he is expecting forward drift.
Yeah. Oh, it's classic.
Right? Yeah, absolutely. Yeah, that's what exactly. Okay, so you got it.
In the absence of convincing experimental evidence, Alex turned to theoretical analyses, like one by MIT aero professor Mark Drella. But here too he found...
So he keeps on going to some physics stuff. We're not going to go into this. But before I tell you what the end result was, what did you hear? What did you see? What did you notice in the way that they both discussed this?
No, it was kind of adversarial, I guess.
Sorry?
It was kind of adversarial.
Yeah, but adversarial are like good spirits, right? What did they do in order to solve this adversary? Got some big names from science. I don't know if you know these guys, but they are some of our best, in communicating science to the public. Very good scientists. And they're the ones who are supposed to help mediate this. Good. So adversary, anything else? How about the language? What did you hear from the YouTuber and from the professor? Yeah. So this is something that I really appreciate. Thank you. And the kind of like the point that I wanted to make about this is that I love the way that he talks about this. Like, I wish we as scientists would do this more. Because if I'm wrong, then I want to know, like, the whole point of this channel, the whole point of what we're doing as researchers, the whole point of what we're doing as effective altruists is to get to the truth and help the world. Like, we don't have any other incentive, and we're willing to put money behind this. Because if I'm wrong, then I want to know up to $10,000 US. But the professor also was willing to put $10,000 US. So maybe it is about the pursuit of truth. What kind of things did the professor point to? How did he explain that the scientific evidence? We see the scientific evidence, but the scientific evidence is not solid. Why? So he had a few explanations, right? For example, he said, the person who is actually doing the experiment, showing this on YouTube, they're creating the effect. It could be deliberately, so in that case, we would call this fraud, but he has a different explanation, and he is 100% sure. Whenever I hear somebody say that they're 100% sure about anything, I have serious doubts about anything that these people are doing, and I'm really trying not to use this kind of language. Many times in podcasts, I hear somebody replying, this is absolutely right. Like, not absolutely right, 100% right. There's always some uncertainty. I'm sure, 100% sure that the guy in the video doesn't do it on purpose. The thing is here is that in this case, he was arguing for subconscious bias in the people who are doing this experiment, but obviously he did not see the possible bias in himself. And it's amazing because in the debate, the adversary between the YouTuber and the UCLA professor for physics, the YouTuber was right and the professor was wrong. And there's the proof. Actually, you can do this yourself. Now you can just, they created this model that you can download and use a 3D printer in order to create your own and demonstrate this. Let's see the proof. I hope this will work.
Does it work?
It totally works.
Amazing.
Oh my god, it's so good.
Her fourth version of the cart works spectacularly, and it was designed to be replicated by anyone, using just a 3D printer and a simple list of materials. She explains how to build it with more details on the engineering process on a video over on her channel, so go check it out. Now, Professor Kosenko has now conceded the bet, and he transferred $10,000 to me. So I want to thank him for being a man of honor and changing his mind in light of the evidence I presented, which is really not easy to do, especially in a public debate like this one. Now, I do not want to keep the money. I want to invest it in science communication. So I'm holding a...
So it's amazing what happened over here. There's lots of things that we can take away from this, which I wanted us to kind of reflect on. Lots of lessons on how we should do science. And we don't actually do science like that very often. We can get some trustworthy judges. We can just do everything as open science, just like this guy did, you know, making everything publicly available, all the equations, all the demonstrations, ensuring that all the evidence is checked and evaluated, getting as many from the community as possible to do this with independent replications, not just his own. Now, my takeaway from this professor, I was just blown away by this. It's like, what would go through this professor's mind in order to go on some YouTuber's channel? Why is it so important for you to force the YouTuber to take down something and tell them that they're wrong? And also to do this without really verifying this. So instead of putting $10,000 on this, he could have just replicated this himself. It takes $5 to put this out in a 3D printer and just run this and see whether this is subconsciously created by the experimenter or whether this is something that's actually solid. So could have replicated this for petty cash. Why not? He assumed bias in others, but did not check to see whether he is biased himself. He was always trying to find evidence to support his own theory and reject everything that he saw in others as something that has to be wrong, because they're not professors, because they're not from UCLA, because they're not. Just a YouTuber, right? To me, combination of a lot of hubris here, bias against replications, which I think is very common, unfortunately, in our science. Just replicate this yourself. It's so easy for you to do. You have a responsibility, even if you're Kahneman, even if you're somebody that comes from UCLA, has a professor appointment. There's bias blind spot over here. And the point that I want to make with this case study is that there's also confirmation bias. And this is another bias that we need to talk about. Once again, HKU students come to the rescue. So this is a thesis student that did a replication of confirmation bias with me. And you can see the extent of confirmation bias if we remember Cohen's d. Actually, these Cohen's d's are very large. If you look at these, they go from 0.37 to 1.3. The thing that we were not able to replicate is debiasing confirmation bias, because confirmation bias was so strong that it doesn't matter in what kind of way we showed this, it still came out. The way that we did this is that we asked people for their opinion, and then we gave them pieces of information and asked them, which of those information do you want to look at in order to see whether you're right or wrong? And we saw that people tend to look at evidence that supports their views just from the titles of the newspaper articles. So if you support, let's say, the Republican, then you will go for Republican pieces. If you're Democrat, you'll go for the Democrat. So you tend to go with the evidence rather than looking for the evidence that might disconfirm your views. Why? Because disconfirming your views is uncomfortable. So confirmation bias is alive and well, and we were able to replicate this with some of the studies. Now I'm going to touch on something that is very uncomfortable to all of us. And luckily for you this semester, we're not doing too much of that. And that is the issue of statistics. Still, I want to ask you some questions in order to reflect on this, because a lot of the demonstrations from Kahneman and Tversky and Kahneman have to do with statistical reasoning. What they were arguing is that people don't like statistics. It's very difficult for them to do statistics and understand statistics. So they try to find, instead of doing statistics, an easy solution that might help them avoid the statistical question. So statistical reasoning is effortful. People try and minimize effort, and therefore they follow their intuitions. So based on experience, people do things based on what worked before. They do an approximation of what is right, and they avoid wanting to rethink what it is that they've done. Therefore, they rely on heuristics, on mental shortcuts, in order to automize all sorts of things. I've done this many times before, just like driving. I don't need to rethink everything, how to steer the wheel, how to shift gears, how to press the brake. I know all of this. I'll just follow my intuitions. I'll go with what's automatic, rather than doing the more rational, slow, careful, deliberate processing. So that Kahneman and Tversky really built a whole model around this. They try to simplify this with system 1, system 2, and all sorts of interactions between these two. And over here, I'll just ask you briefly a statistical question. Hopefully you'll have some answers for me for that. I'm gonna skip the one that we didn't do. Yeah, so this is the question. If we look at this classroom, almost 23, let's say that the 23, if you select any 23 persons at random, what is the probability that at least 2 of them have their birthdays on the same date, except for February 29th, which is kind of rare? Don't look up the answer. Perhaps you've heard of this one before. What does your intuition tell you about this question? How to solve this? How to approach this question? First of all, is this an easy question or a difficult question? How many of you think this is, sorry?
Definitely not easy.
Not easy. What's making this not easy? What's troubling you? What's making you conflicted about this? We have the number of days and we have the number of people. Then what? We need to match 2 people having at the same time, the same day, right? So a lot of tricky stuff, and we know that this requires a little bit of math. Now, there's one brave soul that gave us a guess. Thank you for the brave soul that shared with us. 88%. Why 88? I don't really know. But people generally tend to estimate this as being very, very small chances, right? There's only 23 and there's 365 days a year. So very, very small. Now, the way that people usually approach this is that they have this intuitive heuristic response. Do I know people who have the same birthday with me on the same day here in this classroom? Here we don't know, but let's assume a group of 23 that I know. What is the likelihood that I'll find something? Do I know somebody? No. Then we just, hence the probability is small. The intuitive experience response is there's something tricky here. Therefore, I need to be very, very careful in how I approach this. Maybe my estimates are misleading me. The rational one is, let's just simply calculate this. But even if we want to calculate, do we know how to calculate this? Very tricky stuff. The right answer is 50%. And most of the people who see 50%, I'm just like, what? How is this possible? This doesn't make any sense. Here is the actual math. You calculate how many days of the year don't have a birthday, and then you use that in order to look at all the comparisons, and they raise this by the power of, and then you get how many you don't have, and then you discount this from 100, and then you get 50 point something. So the chance is more than 50. If you go to the birthday problem on Wikipedia, you'll see that according to the number of people that you have, 23 is about half. But then as you approach 60 or 70, it becomes almost 100. So it grows very, very fast. Most people are not able to kind of comprehend this sort of thing, because statistics is difficult for us, and the rational way to calculate this and deliberate this is tricky. Now, this is one that perhaps is going to be easier for you to think about. Let's say they have a newspaper that's 1 centimeter thick, a very thick newspaper. And then you can fold it. How many times do you need to fold it? Time and time again, in order to reach the moon. 100 times? Okay. What other guesses do we have? It's the same brave soul. How to approach this? What seems to be the right approach to this kind of? So one way to think about this is that what is the distance from here to the moon? Right, very distant. Therefore, has to be a very large number, right? However, what's the tricky part? And this is the tricky part that failed us with the COVID, when we didn't understand what is exponential growth. We had this number, the R. If R is 1, then every person infects one other person. If we have R is half, then every person, half a person. If we have R is equal to, then we know that we're in deep trouble, because exponential growth, within no time, the entire city/country can get affected by this. Yeah, so we have like a 10 billion number folding, so I don't think it will come to you as a great surprise. I'll tell you that 35 times. If you take a newspaper, fold this 35 times. If I take this from Wikipedia, where the paper is a lot thinner, 0.1, then you'll see, have some estimates of how many times you need to fold a newspaper in order to get to the Sears Tower, 20, outer limits of the atmosphere, 30, distance to the sun, 50, size of the solar planet, 60, 11 light years, 70, and so forth. That's the thing with exponential growth. People have a very hard time understanding exponential growth. And this is what's so difficult about pandemics. Because you try to explain to people, you need to be very careful in self-isolation, to take care of yourself, to put a mask, because if you don't, and R is equal to, you're going to lose control very, very fast. But people don't get exponential growth. Here's another interesting example, and this is, I've seen this both in the Chinese context and the Indian context. It's the beggar and the king. Let's try and show you this video. That even emperors fall into this trap.
In ancient China, there once lived a great emperor. He had a love of the game of chess and wanted to reward its inventor. He said to the inventor, "Name your reward. Anything in my empire can be yours." The inventor replied, "Oh, Emperor, my wishes are simple. I only wish for this. Give me 1 grain of rice for the first square of the chessboard, 2 grains for the next square, 4 for the next, 8 for the next, and so on for all 64 squares, with each square having double the number of grains as the square before." Amazed the inventor had requested such a seemingly meager reward, the emperor sent word to his treasurer to arrange for the payment of the rice. In 1 week, the treasurer returned. "My emperor," he gasped, "this is more rice than exists in all of China." The inventor had used his knowledge of numbers to...
Yeah, so it's interesting to see that this is actually cross-cultural in its impact, our lack of understanding of exponential growth. So you can see how fast there's actually, not just in China, but in the universe, there's just not enough rice in order to pay the inventor of chess. But this also influences policy, because if you don't understand the risks of a pandemic, if you can't get policy makers to understand what is exponential growth and how, like, within 64 days, the whole universe is gone. You know, if you don't take care of exponential growth. And you can go and read about this, both in Thinking Fast and Slow and with David Hand over here, about all the problems with statistics. And I'll let Veritasium, it's just nice that he also does psychology stuff in order to summarize this for us.
For most of us, thinking is at least somewhat unpleasant. We try to avoid it where possible. For example, I asked these guys, how long does it take for the Earth to go around the sun?
What do you reckon, cuz?
Is it 24 hours?
Obviously a day, yes.
Or take this problem, which has been given to thousands of college students. You go into a toy store, and there's a toy bat and a toy ball. Together they cost $1.10. And the bat costs $1 more than the ball. How much does the ball cost?
10 cents.
We're all wrong, aren't we?
What's my answer?
If you think about it for just a second, it's obvious that the ball can't cost 10 cents. Because if it did, then the bat would cost $1.10 and the two items together would cost $1.20. The correct answer is 5 cents. Now the point of these questions is not that they're difficult. Any of these people could have quickly checked their answer if they wanted to. The point is that they don't check. Because thinking is uncomfortable. It takes effort.
Hey, the Earth doesn't take one day to get around the sun. It takes like a year.
Now I think it would be easy to put these mistakes down to stupidity and believe that you, being much smarter, could never fall into such traps. But then I think you'd be fooling yourself. I think these examples reveal blind spots in all of our thinking due to the fundamental way that our brains work.
This is Dorothy Bishop. Lots of examples I can give, and I give a whole series of this. I can go a whole semester with the biases that we have. But what's interesting about Dorothy is that Dorothy is the one that helped me understand that even we, researchers, can be biased. Why? Because she goes around the world and gives talks about this. So for example, here, the psychology of experimental psychologists overcoming cognitive constraints to improve research. How scientists can stop fooling themselves, fixing the replication crisis, psychology of experimental psychologists, fallibility in science, all these well recognized. She is accomplished. She just retired a year ago, had a big party with all the open science people celebrating her work. If you look at this number of citations, the number of publications, at least 380 publications with 10 citations, definitely a very impactful person who has started the whole movement about us trying to understand how we're biased as researchers. The interesting thing is that Dorothy Bishop here, there's a talk that she gave as part of a meta-psychology conference in 2019, and she studies twins. And she tries to show the difference, how much is nature and how much is nurture. And then she tries to see whether they behave differently on some aspects. And then by that, you can disentangle whether this is more nature or more nurture. And she did a meta-analysis. So over here, she found differences. For example, she summarized her own in 1995. She summarized in 1992. And she showed the differences between types of twins where this shows an effect. And at the height of the presentation comes a confession. And the confession was that she published she did a meta-analysis. And only after this was finished did she realize that she forgot to include a study. And that study was the only study that did not show any differences between these two. So was not in support of her theory as somebody who wrote the meta-analysis and conducted this research. But the most remarkable thing is that I sort of managed to mentally suppress its existence. And that study was done by her PhD student. So if Dorothy Bishop, who is the one who's warning us about cognitive biases in researchers, goes on stage in meta-psychology and admits that she conducted a meta-analysis and forgot to include, but she did not include the one study that did not support her views, because this was done by the PhD student. So I failed to mention this in talks for several years. I literally forgot about this. So she knew about this, but the brain does amazing things in convincing us, only looking for the evidence that is in support of our views, even if we conducted this or one of our students did the study. And that changes the conclusions of the meta-analysis. So confirmation bias is alive and well, is very, very strong, and we need to remember how to do this, even when we search the evidence. So you're doing a lot of searches right now, and we're like, we need to find a citation to support the views that, I don't know, this is affecting charity in some way. But sometimes we need to find support for things that do not align with this. So actually, the way that I search things is that I look at cited by and look at replication, independent replication. So whenever I see an effect, I want to see somebody else do this. I want to see a meta-analysis looking not just at this effect, I want to see the entire literature. So the reason why we're doing this guide of how to establish evidence is because we know that a single researcher can be very, very biased, and we need to check this. This is why we support open science. Everything should be shared with the entire community for everybody to check this. We do cherry picking. New study released that the study validate my preconceived beliefs. Yes, has to be a good study, therefore I was right all along. Doesn't support, must be a bad study. I will find all the flaws, and yep, it's a bad study. I was right all along. So all these things are very powerful within us, and we need to be very careful when we do this, not to cherry pick when we look at the evidence. So we tend to trust citations that support our views, but only supportive materials, but we need to be very careful to check ourselves and do this correctly. I'm going to skip all of this. Sorry about this. And just to show, I think we also did this last year with these two over here. We did assessments. So actually, I asked the students for the first 3 years, 2019 to 2020, 2021, to go and check the literature. At the beginning, 2019, I asked them to check other people's work. And then people were like, hey, why are you checking other people's work? Did you check your own work? And then I'm like, yes, we should check our own work. So starting from 2020, 2021, each group of students always checked the replications that we did from the year before. And then we had 14 and 16. It looks like it was working. Another thing that happened, you can talk to these two over here, is that I offered to pay money. So if you go on my website, there's now I have a check me, replicate me because of Veritasium. I really want to know if I'm wrong. So if you find some errors in my research, if it's a minor error, I pay you $5 US. If it's a major error, I pay you $50 US. And what happened last semester is that a lot of teams found errors in my research with the students, with HQ students, and they helped me. And even one of those was a major one with one of the teams. And then I offered them the option of donating this. And if they donate this, I will match this. And at the end, we donated together $250 US because me and the students from previous years made mistakes. And I'm still 100% sure that there are more mistakes in there, because we always have mistakes in our research, and we have to check ourselves, and we need to be humble, and we need to share as much as possible. And we can't do this if we don't invite, incentivize, and open ourselves to criticism. One of the things, the third task, this one. The third part of the second task, it's optional. You don't have to do this, but if you want to, I invite you to try and contribute to GiveWells. So the nice thing about some of the groups in effective altruism is that they open themselves to changing their minds. They want you to attack their methodology. They want to know if they're wrong. So if you go to GiveWell, if you do a good entry, we'll submit this together to see perhaps there's going to be a prize. We can donate this, or we can use this for something else regarding science, where they offer $20,000 US for the winning first place, 10,000 second place, 5,000, or even participation $500 US, just for helping them improve their methodology. Have you heard of any HKU professor opening up their research like this? I really wish we did more of this. I would love to do this as scientists. We need a bit more humility, and we need to invite the world to contribute and attack our methodology and help us to improve. So this whole session was about us to recognize our cognitive biases, that this affects us in research, that this affects the way that we look for evidence, the way that we implement evidence, and we need to be very humble about what we do. The third task that we will have is about cognitive biases in the way that we do charitable giving. So all sorts of things over there. This is just an introduction to cognitive biases and how they affect not only researchers, but also policymakers and people who want to do good in the world. Any questions, things you want to talk about regarding this lecture? Some interesting case studies. I encourage you to go and have a look and see the entire episode. Some good stuff, Veritasium and otherwise. Going back and summarizing what was at the beginning of the session, in case you forgot, I invite you to tag me on Slack, tell me what's going on. If you felt uncomfortable talking to me directly, you have the midterm evaluations. Please write your opinion, be critical, tell me what it is, complain, that's completely okay, and I will hear and I will adjust, and I will let you know next week what kind of solutions I might have for you. But I do want to help you. For that, I need to know what's going on with you. So reach out and I'll help you with your projects and this course. See you next week.